All right, so let's start taking a look at Google Cloud Platform. So in this first module, I'm going to talk to you and show you what GCP is all about and how it is organized. So I'm not going to get into like creation of virtual machines just yet. That's going to come a little bit later this morning. First thing I want to do is I want you to introduce you to GCP. Now, what is GCP? GCP is using Google's data centers to run your computing workloads or other computing needs. Okay? It's on-demand self-service. You don't need to call anybody. You don't need to have somebody build you something. You, using a click type interface, using a web interface, using your web browser, or using programmatic interface, using APIs, or using command line tools that we provide through the Google SDK, we can go and we can interact and we can build things on GCP. It's got access to Google's massive scale network, which is actually one of the largest private networks on the planet. And we'll take a look at that here this morning a little bit. We've got resource pooling in that Google can share the underlying resources. So when you're using GCP, you've got access to, say, some of their hardware, but you can shut that hardware down. You don't need it. And Google can use that hardware or somebody else. So we can take advantage. So if you have very bursty or you have different needs in the daytime than in the night, etc., we can go ahead and leverage that. Rapid elasticity to rapidly scale things up and equally scale things down. So you're basically paying for your usage on there and you're able to get lots of resources. This afternoon, I'm going to demonstrate you a 1,000-node Hadoop cluster that I'm going to spin up in about 90 seconds. Okay? Just to give you an idea of the sort of scale of what we could do. And we pay for what we consume. All right, so how did we get here? You know, we used to build our own data centers, or if you weren't big enough, you co-located. You went and rented some rack space. I used to rent rack space outside of Chicago for running some of our operations. I had half a rack, about 7 servers that I owned that put in there. What did we do? Well, then we started to, we still had our own hardware, but we virtualized. We loaded a hypervisor, and we ran virtual machines. And that made our life a little bit easier, because when we installed a new app, we didn't have to load it on hardware. We instead loaded it into a VM, and now we could move that VM around. Well, that's what we could do up on Google. In fact, up on Google, we could go ahead and run our virtual machines up there. And so Google owns the hardware. We own, we control, we secure, we handle the VMs. And no, on a random Saturday afternoon, Google doesn't go in and poke around your VMs. They don't actually even have access to your VMs unless you, in working with your Google team, actually need them to look at that. You have access to your resources. But times are changing even that. You know, in my career, I've gone from physical servers where we had to load everything directly, then to virtual machines. And now we're moving to serverless, where we don't even have a server to worry about. We can utilize Google's App Engine product, where we can give Google code, or we can give Google a container and say, Google, will you please serve this to my customers and scale it up and down? And I just want to pay for the computing time that it actually takes you to deploy my application. Or I want to run Node.js or Python or Go functions up in the cloud using the Cloud Function product, where literally I trigger those to happen via a web URL, or a file gets put into a bucket and I want to trigger an event to occur, or schedule it based on time, trigger that event to occur, have it run for the milliseconds it need to run, and then go away. So I could do that with Cloud Functions. So I could deploy my functions up in the cloud. I could do my containers up in the cloud. But more and more, we're moving away from not having to worry about, well, what's underneath that stuff. But if I need the control of a VM, if I need the complex container orchestration, I can still do those as well, but more and more things we start to see where Google just says, let us worry about the servers, you just worry about what you want to do. We know every company is a data company, and they're not, you know, and the term big data really doesn't even need to be big anymore because data is just data. There's just a lot of it. And so around Google, we do a lot of big data processing. So at scale. I mentioned the other thing we're going to be doing today is we're going to be looking at BigQuery. At BigQuery this afternoon, I'm going to run a really large query for you. So around the scale of about 4 terabyte query against data that's going to come back in less than a minute. We can process through billions of rows of data. So again, big data isn't big anymore when we've got the power of Google behind it. So these are sort of the various aspects of Google Cloud Platform when we think about traditional computing infrastructure. If I need a VM, well, that's infrastructure as a service. I'm asking Google to provide the infrastructure. I want to run the server. So we call that on Google Compute Engine. If I have complex containers, so I've got I've gone for a microservices design. I'm using Docker or other container type platforms, and I want to basically coordinate the running of all of my containers. Well, then we turn to Kubernetes. Now, Kubernetes started at Google, but has been open sourced. It's a large-scale container orchestration platform, and that's how Google runs a lot of that. So all those wonderful apps you're used to using on Google that have 1 billion+ users, yeah, Google has 7, or I think it might even be 8 now, billion user products. Now, how many of you would like to have to deal with 1 billion customers? Some of you are shaking your head going, oh, that might be too many. Yeah, well, Google deals with billion customers, and this is the platform they used to deploy that. When's the last time you saw google.com down? When's the last time Gmail wasn't working for you? When's the last time your Google Drive? When's the last time 8.8.8.8 wasn't working? Anybody know what 8.8.8.8 is? Yeah, a lot of heads nodding out there. Google's DNS, yeah, that's all part of GCP. Now, as we move from the left to the right, we see compute, VMs. Kubernetes is complex container orchestration. App Engine is deploy either a single container or deploy just straight code. Python, PHP, Go, Java applications directly on Google and ask them to do that. And then Cloud Functions is a function-based programming. So I have a Node.js. Anybody work with Node? Okay, deploy a Node.js function on Google. Hopefully by the end of the day, we'll give you the tools where you could actually go try that stuff out. And then into the managed services that we can use to literally run Google, or run our applications using the same tool as Google built to build theirs. So this is actually a map of Google's network. This is not the internet. This is Google's private network. It spans the globe. Okay? Now, to give you an idea, when you go to a resource that's running on GCP, it actually enters Google's network at the nearest place and then travels across Google's network, which consists of undersea cables and cables buried down alongside railway lines and other places between cities. So when a company like yours has to go, if you have 2 data centers, one maybe in Philadelphia and the other maybe up in Boston area or something like that, you guys just pull out the company truck, dig a trench between Philadelphia and Boston, run your own fiber optic cable, and you're good, right? No? Oh, well, that's what Google does. There's over 100,000 kilometers of fiber optic cable that Google uses to interconnect their networks. And that changes the way that you can do some of your networking. Now, the other one is, see all those little all those little round dots? Think of those as the on-ramps to Google's network. So I recently got back from a trek. I was over in India, and I was working in Chennai, so down on the southeast coast of India, right on the Bay of Bengal. Well, that is actually one of those points over there in India. And when I accessed resources that I had running back in Google's central region, it was fast. Why? Because I got on the on-ramp. Literally, my last mile was that segment from my hotel to the entry point to Google's network, and from there, it was literally down the pipe and all the way along. And then the return traffic. It wasn't put it out on the internet and let it ping pong or hot potato around the network. It stayed on Google's network that whole time. Now, you start to say, okay, but what about here in the US? Well, I can start to build applications that are actually running in 2 places. So I could have servers on the East Coast and the servers on the West Coast, serving my customers. So if we think about a common 3-tier application with a web server front end, some middle tier Java logic, and a back-end database, I can deploy those front ends closest to my population of users, because that's where they think the speed is, what it takes for them to load my page and things. And then my front ends can be talking to my middle tier, and then my middle tier can be talking to my databases. And some of those things I don't want to have in one place. I want to have them in multiple places for redundancy and disaster recovery and failover. And this network is going to let us do that. Now, Google has organized things They've organized things in a couple terms. And even if you've had worked on another cloud before, the terms are specific to Google or the way that they implement them. And in fact, we talk about on GCP zones and regions and multi-regions and then sort of the globe. But I think the easiest way is to actually show you something. So we're going to go on a little tour. I'm going to switch over to my laptop here, and we're going to go look at Google's first data center. Okay, if you do some digging around, you can actually find Google's first purchase order where they co-located and they rented space. And then they go and they say, it's time for us to build our first data center. So they do this, and they actually do it at a place kind of dear to my heart. I grew up in Portland, Oregon, and just up the river from Portland, Oregon. So here's Portland. Seattle's about a 3-hour drive north. We go way south. We're down in the Bay Area, where I guess there's no power right now. We go down that way, and that's about 13-hour drive. So I grew up in Portland. But when we wanted to have fun or scouts or things like that, we'd actually go up the Columbia River. So this is that same Columbia River that Lewis and Clark went down, and we go visit the town of the Dalles, Oregon. Now, why did we go there? Well, there was a gigantic hydroelectric dam here. And if you're going to build a data center with 100,000 servers plus in there, what are you going to need? Lots of power. So I like to think Google plugged their extension cord into the dam, ran it up the river, and they built their first data center called US West 1. But the first thing I want you to realize is they didn't build a data center. They built multiple data centers, and they built a campus. Now, on GCP, we refer to things as regions. And a region is a regional data center campus on Google's network. So there is the US West 1 region. There's the US East 1 region down in Moncks Corner, South Carolina. There is US Central 1, which is in Council Bluffs, Iowa. These are not cities you usually hear of. But when you're building big, massive data centers, you need lots of land and power to build them. Now, we've also seen Google open more specifically targeted data centers, like one in Northern Virginia for mainly government. If you think about, okay, Virginia, yeah, if I want US government, that's a great place to build a data center. They've built one outside of LA. So they've built one called US West 2 out in LA, and that's another data center, but it's in LA. So it's got specific sort of target. The big general purpose ones are ones like US Central 1, right in the center of the US in Iowa, US East 1, US West 1 up there in Oregon. And so when they go to build it, they literally take apart the concepts, say, what do we need to do? We need to make sure that even if we have a disaster of a human level, equipment failure, fire type sort of thing, let's build 3 data centers on this campus so that even if we have a problem, we still have 2/3 of the capacity in that location to keep running Google products. Okay? So Google will put these onto a campus. Now, so this was the first one they built. So they're following their rule book. Let's go back to we'll stay on my picture here. What we've got is, so there's 3 buildings here. So when you see Google refer to zones, I want you to think in your head and say, okay, we have 3 zones, 3 buildings, coincidence? I think not. So when you see Google zones, I want the picture in your head to be, well, I'm going to deploy that VM in US West 1A. So maybe I'm deploying it in this building. And if I'm going to deploy the application, I can also run it in US West 1C. So the US West 1 regional data center. And then I'm doing the C data center there. Now, this was their original design. And it's all mapped out in what they called their SRE, their Site Reliability Engineering, which on Google is their rule book for DevOps. In fact, if you go up and you just look up GCP SRE and you want to know how Google works, this is where we go. We go to Google's Site Reliability Engineering, how they run production systems. They put all this together into an SRE book, and they've now got a workbook that goes with it. You can read all this online. And I'm going to just kind of give you a little snippet out of one of these chapters here. We look at the production environment on Google. They talk about a hardware. Machine is a piece of hardware, or VM. A server is a piece of software that implements a service. They say tens of machines are placed in a rack. Racks stand in rows. One or more rows form a cluster. Usually a data center building handles multiple of these clusters, and multiple data center buildings are located close together to form a campus. So here we are. We got a couple data centers, and we got a big mountain in the background. Well, if I go back to my map, and we zoom out, that's that mountain right there. This is Mount Hood. This was basically their book that they said, we're trying to accomplish so that if we have small, typical failures, everybody, you can't have something 100% available. They will have accidents. They will have things happen to a data center. But if there's 2 more on that campus, human error, equipment failure shouldn't cause everything to be down. But what could cause everything to be down? I'm going to zoom out just a little bit. We jump in our time machines. We go back to 1980, May 18th. I was growing up in this area. I think I was 7. And Mount St. Helens decides to blow its top, covering the whole region with ash and all this sort of stuff. What do you need to do at that point? Having another data center 10 miles down the road, do you think that's going to help? If there's an earthquake, if there's massive power outages, if there's, a tornado or a hurricane or whatever coming, that's going to happen anywhere in the world. So what do we need? We need more data centers. And so we go to GCP's zones and regions, and we find out that Google is running 20 of these regions around the globe. Okay? West, we were up here in Iowa, all up and down the East Coast, LA, all over Europe, South America. These are all the regional data center campuses. Those are known as regions. And then the zones are how many either physical or logical now. Because after you build your prototype, what do? You always look and say, what did we do right? What did we do wrong? What are we solving? What are we not solving for? Do we really need to have 3 buildings, or could we collapse those into a single building with good solid concrete walls for fire and still operate them like 3 logical data centers? And that's actually what happens. If we go look at their first Europe operation, St. Gozlan, again, not a town that you're used to hearing, St. Gozlan, Belgium, outside Brussels. We got to zoom out to even see Brussels up here. But if we zoom in, we're looking for a really big building that can probably be seen. And that really big building might have started like this. Do you see the 3 data centers? I see 3 wings to a data center. And I see a gigantic 2D barcode. Now, that barcode says google.be. Okay, so that gives you the idea of the zones and regions. Now, the thing is, you then build more data center, and you build more. And that's now Europe West 1, and Google's got data centers like this all over the globe. So it no longer really follows physical buildings, but zones are still a very important concept. It's like a logical data center within Google's infrastructure. We have logical zones on the network and then make up regional campuses. So let's jump back to the slide deck here. But I just like to give you that sort of virtual tour there so you get an idea, because one of the first tricky subjects in working with GCP is where am I going to run my resources? So for example, here, our zones, we're referencing Europe West 2. Well, the Europe West 2 region is in London, in Slough. So a lot of financial institutions, things like that, based in London. And then within London, there is 3 zones, zone A, B, and C. And when I build a VM a little later here, we'll see that that's where those are being deployed. The regions. Now, there are other products on Google where we'll actually deploy things to be region or multi-region. When I go to store data in a bucket, I don't worry about the zone at that point. I say, Google, I would like to build a bucket in, I don't know, pick a location. Let's build it in the central of the US. So I could choose to build it in US Central 1's region. Or I could just say to Google, you know what? I'd like a bucket that is actually deployed globally, or sorry, regionally, multi-regionally. I'd like that bucket to be deployed in the US. And then Google will put that data in at least 2 of the data centers in the US. Or I can ask for a bucket to be deployed in Europe, where it's in at least 2 European locations. And we can take advantage of Google's scale, and we can take advantage of that network. So on Google Cloud Platform, here's what we just looked at. Now, you actually see, if you took a note on the slide, the Google page I just came up, there's even more data centers on the way. You know, we've got there, the little white dots on there are future data centers. Google's actually announced 2 more in the US. They've got one coming in Salt Lake City, and there's another one opening in Las Vegas. So there's going to be 2 more data centers in the US that Google can use as part of GCP, all connected through that high-speed fiber optic network around the globe. But in addition to that, Google is committed to environmental responsibility. There's 100% carbon neutral since 2007. In fact, there's a great new article on their data center up in the Netherlands, where literally it's green. I mean, all their data centers are green. They are all about renewable energy, you know, with their data centers, and they've achieved ISO 14001 certification in their data. They were the first data centers to achieve that. So they're committed to the environmental responsibility in running their computing infrastructures. There's customer-friendly pricing. We run things in either sub-hour, and many things run billable by the minute or billable by the second. So when I'm running a compute engine, that VM runs a minimum of 1 minute, but after that I pay for its operation by the second. Oh, it's like 5 cents an hour for a CPU. So take 5 cents an hour, divide by 60, there's your minute, and divide that by another 60, and now you're down to per second billing. Discounts for sustained use. Over the course of a month, if you're running a VM just for a day, you're paying sort of the base price. If you run it for more than a week, discounts automatically start kicking in up to the point that when you run it for the whole month, you get even a larger discount. You can also commit to specific usage on GCP and even make the pricing even cheaper. And that way Google can plan on their capacity they need in different locations. They have a special type of VM we can ask for, a preemptible instance, which is Google's spare computing capacity that you can get at an even deeper discount. But if Google needs it back, we give it back. It can be preempted. It can be taken away from us. But in exchange, we get things for around 30 cents on the dollar for the computing. Now, what are those used for? Not for running your website, but they're useful for if you have data processing needs that doesn't need to be done right now. You know, when the computing resources are available, I'd like to get this work done. And so we can go and ask for preemptibles, and we can build a VM to our exact needs. We can choose the number of CPUs independently of the amount of RAM we have. We don't have to go for cookie cutter style computing. Google's got some pre-built sizes, like an N1 standard 1, which is 1 CPU with 3.75 gigs of RAM. They've got an N1 high mem 1, which is, or actually a high mem 2, which would be 2 CPUs and I think it's about 13 gigs of RAM. Okay? But you could also build something anywhere in between and pay for, well, what your CPU needs and what your memory needs. And Google will actually make that recommendation to you on your VMs. There's open APIs to go work on Google. So we can go and we can programmatically interface with GCP. We can go leverage, if we have an HBase application, we can use Google's Bigtable, which has an HBase API that we can go and work with. We could take advantage of Pig, Hive, Spark, Hadoop, those sort of tools on Google's Dataproc. Google's also taken a lot of their tools and they've open sourced them. So TensorFlow, which is one of the premier machine learning libraries out there, Google started at Google and they open sourced it. Now TensorFlow.org runs it. And so universities and research institutions and everybody is contributing to the further development of that. So they've taken their idea, what they used initially, started in-house, and moved it out. The same thing with Kubernetes. Same thing with Forseti Security. All these sort of tools are basically tools that Google is using, but they also are tools that you can use on-premise and even in other clouds, where we use Google where it makes sense for our organizations. And then multi-vendor friendly technologies like Stackdriver, Google's monitoring platform, can work for both Google resources as well as AWS resources. Kubernetes engine, it's used on-premise. It's used up in Google, and if you attended Google's Next conference back in April, Google is launching out Anthos, which is a multi-cloud solution for managing Kubernetes clusters. So all of these things basically contribute to what we do on GCP. Now, as far as security goes, Google takes security seriously. Everything they build has security basically from the ground up. right to, at the very bottom there we say the hardware infrastructure. Google designed a special chip referred to as a Titan chip, and that Titan chip is used to protect the motherboards on their servers in their data centers to make sure that they have not been tampered with before that is even allowed to boot and to begin running your VMs. Encryption is occurring everywhere throughout Google's network on many different levels. Their pipes, their network is already encrypted back and forth. And your data flowing across that lives on a virtual private network. Your files are encrypted at rest. Files are encrypted during transit when you're using buckets. Your disks on your VMs are encrypted. User identity, we have, Google's got central identification service. That service you use for your Google login, your Gmail, or if you're using G Suite. How many of you using G Suite out there? Your G Suite credentials, all of that lives in a large central identity service with two-factor authentication and other things. There's storage. Things, as we said, are encrypted at rest. Internet communications. Communications, if we're securing them, our applications over an HTTPS connection, Google can be part of that connection with their global load balancer and their other components of the network. So using Google as a front end to your application. Google's got denial of service in many components of their network automatically take care of a lot of denial of service needs. But that doesn't mean if your application gets really popular all of a sudden that that's denial of service. No, your popular application needs to keep being served. So it does become a partnership. Google really becomes the partner in the way you operate your network. And so we've got tools like Cloud Armor to work with our front end. We've got Cloud Identity Aware proxies. So for applications that may not have a great security component, we can put Google security in front of that. So before we even get there. And then operational security. Google is constantly watching, understanding what the attacks are happening. They've got the capacity out there that, denial of service by pure bandwidth, not going to get anywhere near Google. Nobody's got more bandwidth than essentially what Google has there. They've got a lot of techniques internally for risk and things. So with all this together, these are the reasons you want to go and utilize GCP to build, to test, deploy your applications, and make a good, highly secured environment. So we start off talking about Google from compute, Kubernetes, App Engine, and Cloud Functions. So those are your computing options. And Google is always adding more to there. There's one in beta now called Cloud Run. So put that on your list of things. Ooh, I need to go find out what Cloud Run does. All right, storage. HBase compatible database in the form of a wide column, big table. Cloud storage for blob data. Cloud SQL, managed Postgres and MySQL. Cloud Spanner, which is Google's horizontally scalable SQL that underpins a lot of those billion user products that we're seeing, as well as a pay per operation database. Pay for reads, pay for writes. So a document style database where you can write rows and read rows back in a schemaless structure. Big data tools, BigQuery, writing large-scale SQL-based queries against tables of data. PubSub, messaging infrastructure for joining applications together and becoming event-driven. Dataflow, Google's Apache Beam execution platform for executing Java or Python code at scale. Dataproc, Hadoop, Pig, Hive, Spark. Data Lab and Jupyter Notebooks, ways to go and interact with interactive Python workbooks and have those utilize GCP. And then all the fun machine learning things that we're seeing more and more of built into our day-to-day products, but you could also put into your own products directly in the form of language and vision and machine learning and translation and things. So a little bit of a quiz here. What are some of Google's pricing innovations? Well, we've got sub-hour billing. Actually, many things bill by the second. Sustained use discounts. Compute engine custom types. You'll see me build one of those a little later. And some benefits of using GCP: environmental responsibility, open source technologies, the robust infrastructure in both the computing as well as their global scale network. So in the slide deck, you'll find that there's a lot of references at the end of each of the sections here that talk about how to go about finding more information. But the real trick is just use your favorite search engine, which is? Google. Google, thank you. All right. But yeah, and the way I always find things in GCP is I always do a search and I put GCP and then what I'm looking for. And almost always gets me into the documentation or it gets me into good clinical practice. That happens about 1 out of 10 searches. You wind up, because you weren't quite specific enough, but most of the time you get into good Google Cloud Platform stuff. Okay, so I'm now going to take you through how we get started with GCP and the concept of what Google has as a project. So I'm going to go ahead and start by showing you a project, and then I'm going to build one, okay? So I'm going to flip over to my laptop here so we can just get an idea. So everything to organize it within GCP is done through the Google console or the API or other, and we see up here that I'm currently in a project called ROI Virtual Classroom. It's actually got an ID here called ROI Virtual Classroom, which has to be a lowercase letters, numbers, and dashes. So I've got a few other here. I've got an IoT demo, I've got a global roaming, and I've got another one for one of my colleagues. Now, I'm selected into this project. This project is where my VMs are going to live. So over here, I'm currently running a VM. Over here, I've got App Engine running. So I've got a small application deployed in here. I don't have a Kubernetes cluster right now, but this is sort of my central dashboard when I'm using the interface, and I target towards a project. And then that project has permissions as to who can do what. The project has billing, who's paying the bill for that, what billing account is associated with that. So I'm going to go ahead and build one here this morning for us. So I'm going to go choose up here, and I'm going to build a new project. Now, I'm going to build a new project. I'm going to call it, let's call it GCP Philly, right? Did I spell Philly right there? Yep. All right, cool. I got to link it to a billing account, so I'm going to link it to a classroom billing account, so that's who's going to pay the bill. So it's rolling up into my central bill for GCP, this project. And then I have to decide where I'm going to build it. And I've got a couple organizations, and we'll talk about those in just a second. I'm going to put this one into an organization called ROI GCP that we use for training. And I'm going to put it into my folder where I keep track of all of these. So this is Grant's project. And I'm going to say create. Now Google's going to need about a minute to create that. And this is now my resource collector. You know, the project is the basis for everything you do on GCP. So a little later this morning, we're going to give you access to Quick Labs. Quick Labs is going to give you a project that's tied to one of Google's billing accounts so that you can go in and play with GCP to follow a lab. And that gives you the steps of what we want you to do on GCP, as well as where we need to go with it. Okay, so if we've got our project, and we've now got our new project has been created. Now this project lives in a hierarchy in an organization. If you were to take your Gmail account and go and build a project like I just did, that would be a standalone project. It would live all by itself, and you're in complete control over that. You can actually do that. You could go sign up for a free trial on GCP, use GCP, and then build something new, something exciting. In fact, Google will give you a $300 credit for that, and they'll also give you some free usage every month. I'll talk about that near the end of the day. I'll come back and review that because that also gives us an idea of all the different products we learned today. Now, if you're in an organization, if you're in an enterprise, you're going to want to have a hierarchy. Those of you already using G Suite, you already have your hierarchy. Your organization is already defined. You just need to decide how are you going to use GCP? How is it going to bill? How is it going to be organized? So over here in my hierarchy, I have an organization. So if I take a look, this is what we use for our training environments, for our instructors, and also for demos and things like that. So we have an organization called ROIGCP.com. That's an identity platform back behind the scenes. We then have folders underneath here that are used to organize these projects. So under my classroom accounts here, I've got some like a GCP healthcare. I was doing some demos in GCP healthcare. I built a project. I was teaching a class over in Kentucky, and I built just a project there. I've got one here in New York City, GCP instructor. Now down here is my folder. This is where I've just built GCP Philly. And I've also got my own project, and I've got another one here. And so I can organize my resources in GCP using an organization. So let's jump back to the slides for a minute, and I'll give you a couple slides that might help, but I'd like to show you that part first, and we got a project built. So when we first start thinking about GCP, we might be focused on, I need to build a VM. before you start thinking about that, you really want to think about, okay, how am I going to organize this? How do I handle this on Google? And that began with the project, and then we build our resources. So we often talk about, whose responsibility is what. So if we are on-premise, you handle everything. If we ask for a VM, well, we see Google's going to handle the operations, the access, the network security, all that other stuff, the white column down the bottom, and we're responsible for the orange up the top, the consent and the policies around it. But remember, access and authorization and all that other stuff, that's all handled by Google. All that stuff down below. If we go and ask for them to run us a platform as a service, so I want to give Google my web pages to run or my web application to run, well, then I don't have to worry about quite as much. And then when I go to full managed services, I worry about even less. I can focus on my development, my use of the application. So this hierarchy that Google put together was to help organizations handle how they handle the access control, how they handle the billing, how they handle the organization of resources. And it really works kind of on 4 levels. So at the top is your organization. That's what I just showed you. Mine was ROI GCP. Then in there I had a series of folders that were used. Folders are just like folders on a lot of other things. What do you use a folder for? Holding stuff. Okay, in this case it holds projects. And then projects have the resources we need. We don't put projects in projects. We put project into a folder, and that folder lives in an organization. If you're not complex enough to need folders yet, you can put projects right underneath. The organization kind of can act as a folder too, but a lot of organizations will have many projects to run because each project they might need to have different security around. All services we do, everything we build on GCP will link back to a project, okay? We use it to track billing, quota usage, billing, resources, permissions, and also what's been enabled and what's not been enabled in the form of APIs. Every project has 3 things. It has a project ID that must be globally unique. We created the project called GCP-Philly, and when we're done here tonight, you know what I'm going to do? I'm going to delete that project so that all the resources in it go away, and it stops all my billing. So that's what Quick Labs is going to do. It's going to create you projects, give you access, let you go build things. It'll be enabled for doing certain things in GCP. And then after an hour or a half hour or however long is allocated for the lab, they'll clean it all up so you don't actually leave things running. Now, a project also has a name. It doesn't need to be unique, it's a descriptor. The unique part is the project ID, and that's defined at creation. And then Google will assign a project number that they're really using behind the scenes, sort of on billing and stuff, because it's easier for them to use a number to track the resources. There's also a lot less space. A 64-bit integer is only 8 bytes, whereas a project ID can be longer. But programmatically, when we go talk to GCP, we reference the project ID. Now, folders just give us flexible management. They give us for organization. And the larger the organization gets, or the more complex the organization is, you will often need folders to help you just group and organize your projects around. But everything is about the project in GCP. Okay, they give us flexibility because I can also go and assign permissions, and I can assign policies. So permissions like who's allowed to do what in that particular project, and policies are what are we allowed to do within there. And let me go back one actually here. We can also apply things high up and they inherit down. So things applied at the organization work their way down to all the folders and to the projects within that. Permissions assigned to the folder apply to all the projects in there. So it's a top-down, accumulative inheritance model. Now, there's some special permissions to get assigned places, like who's allowed to manage the organizational side of things. That's a pretty powerful component of GCP to be managing the organization, just like pretty powerful component whoever's managing your G Suite. If you're using, if you're using Gmail and Google Drive and all that for your operations. And then we also have permissions who's allowed to create projects. And when it's just you'll be the one creating projects. But as we get larger and larger in organizations, we often want to automate that. We want to have tooling, where maybe the user submits a ticket and a project gets created associated with a billing account and they're assigned a permission to it. So that's where we get into this hierarchy of managing GCP. So here's an example of, we've got example.com as our organization. The example goes to a project, has Bookshelf, and it has all the resources inside of it. And so we've got compute, we've got App Engine, we've got storage. And if I put permissions at the org, they will apply down below. Okay, so we refer to this when we start working with permissions on GCP as IAM, Identity and Access Management. Now, identity and access management is who can do what on what resource. Okay, so it's who can do what. So I could take a user, somebody who has a Google credential, your Gmail account, your corporate, if you're using G Suite, or possibly even one that we're using through synchronization tools from our enterprise directory, which might not be Google. Might be an on-premise Active Directory that we're pushing accounts over so they can be recognized. Some identity that Google can recognize, and then what are they allowed to do? So the who, as we said, could be a Google account or a cloud identity or a G Suite identity. It could be a Google group. It could be our G Suite, or it could be an account we build that's what's known as a service account, which doesn't have a username and password. It's for automation. Okay, it's for doing server-to-server communication. That part, as you get deeper into Google, you'll learn more and more about the service account. But initially here, it's your identity or a group that you belong to in Google. And then that identity is given permissions as to what can it do. Now, in this area, we can start at the org. We can apply permissions, and they apply to all the projects, so our super type users. We can have folders in the middle there. And then underneath, we can then have multiple projects. Yeah, this is the one I was after. So we've got a project called Bookshelf. We've got a project called Static Asset. We've got another project called Stream Ingest. Those are all managed by different teams. The Static Access might have a bucket that's got images that we use to serve on a web application. So those are static assets. Who has permission to that? Another, the Bookshelf, who's working on our Bookshelf application. They have certain permissions. And then the Stream Ingest. Well, that's a BigQuery and a pub sub. So we're doing some event-driven architecture over there, streaming data into our BigQuery data set. We can have different permissions on there, and we can decide what permissions they get. Now in Google, we have 3 real types of roles. One is called a primitive. And the primitives on Google are the owner, the editor, and the viewer. And there's a couple other ones that have kind of got in there, but they're done on a project level. They apply to everything in that project. We also have predefined roles that Google has for us, which are predefined roles to do specific things. And then we could even build our own custom role. So we then say, well, what can they do? What can that user do? So here's the primitives: an owner, an editor, a viewer, or a billing administrator, somebody who can manage just the billing. They get to do certain things. But we can also say, well, I don't want them to have the whole project. I just want them to worry about one part of my system. So we build a predefined role. And then beyond that, we can even build our own custom roles for this. Now, I'm going to go ahead and show you this just a little bit so we can get an idea on this new project we've created. So I've got this new project called GCP Philly. Okay? It's in my hierarchy. As we said, I've built it in my ROI GCP organization, down in the folder called Instructors, inside the folder called Grant, and here's my project. When I go look at IAM, we're actually going to see there's a whole bunch of permissions. Doug's got permission to this project because he gets it from the very highest level because he was assigned that at the top. He's one of my other admins. Now, somebody else here, let's see, I think there's somebody, let's see, here's a Google admin. They've got permissions coming from above. Jeff here, Jeff's got permissions from above because they're inheriting down to him. Now, I'm going to add somebody else here. I'm going to go ahead and add, let's see, we're going to add Matthew at roitraining.com. So I can take Matthew and I can go ahead and give him a role. So here's those primitives: the owner, the editor, the viewer, and then a fairly new one called a browser that just has that could only see high-level things. But guess what a viewer can do? View everything in the project. Good answer. Now, they can view everything, but they can't change anything. The next powerful is an editor. An editor can view everything, and they can also change, but not everything. They can't change permissions. In order to change permissions, you must be a owner. So if I wanted to give Matthew full control over this project for everything but permissions, because if I give him permission, if I make him an owner, he could take me away. Well, actually, he can't, because I've got my power coming from above. But he could take people who are directly assigned permissions. So I'm gonna give him editor. So that would let him do what he needs to. But I say, wait a minute, I don't need him to have access to everything. He's only responsible for running my virtual machines. So instead of giving him access to the whole project, I could instead go give him access to, well, virtual machines are run under a component called Compute Engine. And so, if I scroll down here far enough, there we go. There's Compute Engine. And Compute Engine, I could make him an admin for all of Compute Engine, or I could give him specific access. So these are pre-built roles that Google's had. So they say, okay, we could give him Compute Engine. But what if I say, well, I don't really want him to do that. I would like him to be able to stop a VM and start a VM, and that's all. Okay, now we're getting into nitpicky security, aren't we? But we can do that. Not through a predefined roles. These are roles that Google pre-built. We could go and we could build our own role. We could actually go down here to Manage Roles. I can go in through Manage Roles here, and I could actually create a role and give him specific permissions. Now, when I go down here and I give him permissions for the general availability commands, not any alphas or betas, general availability, and add permissions, there are 2,286 permissions as of today. See that number down there? 1 of 10 of 2286. Yes, there are 2,286 different permissions. Why so many? Well, I can go find, and I can give Matthew permission to just, well, let's look for, we could filter and say, well, what does a compute admin almost always have? So a compute admin, there it is. A compute admin normally gets these 417 permissions because he's allowed to, well, down here, instance get, instance delete, instance create, instance list, instance reset, instance start, instance stop. So I could say, you know what? I just want to give him those. What do those sound like? Compute instance stop, compute instance start. Those sound like commands or API calls. So enterprise customers a couple of years ago came to Google and said, hey, Google, we're going to need more permission control than just owner, editor, and viewer. We're going to need to be able to build our specific controls. And Google said, how about we put permissions on most every API? If you need that nitty-gritty, it's there. Now, not all of us need that, but a lot of customers do need that. And that's where we use this sort of thing. So we can do that on GCP. All right, so let's flip back. All right, so we've got these predefined roles. We have the primitive roles, and we have the custom roles that let me build exactly what we need. We have a concept known as a service account, and I'll give you a little bit of that. I'll point that out when we're creating our VM, but that's really as you get more and more into GCP. It's not something you want to try to tackle your first time into GCP. This is how things run behind the scenes when a VM is running. That's where we use our service accounts. But they get given permissions just like our users do. So they are our way to give a server an identity rather than a user an identity. So it can go and interact with resources. So we use service accounts for doing a lot of automation. You might, if you use Jenkins, your Jenkins, you may give a service account authentication file to in the form of a JSON file. And that way your Jenkins can go and copy files into a bucket, knock on Google's door, say, hey, I've got this service account authorization. And it can go do what it needs. On-premise systems that need to interact with Google, all of that can happen with these. So as I said, I'll point them out a little bit later, but really we need to spend some more time together just than a 3/4 of a day here together. We need to go through some deeper training, or as you get more and more on Google, you'll figure out how to use the service account, or your developers will. So behind the scenes, all the identity is handled by Google users, Google groups, either standalone accounts, G Suite, or if you're not using G Suite, we establish what's called the cloud identity domain using your domain. We tell Google, these are where my users are coming from. If we already have a directory, we can actually use a Google Cloud Directory Sync that you run on-premise in your Active Directory, or other directory, LDAP directory service that pushes and creates the equivalent counts over on Google. We can use single sign-on if you've got SAML 2.0 to go back and reference that same architecture. So we interact with Google several ways, and you're going to see me use at least 3 of these today. We're going to use the Cloud Platform Console, the web interface. We're going to use the Cloud Shell and the SDK, the command line. Actually, the Cloud Shell is a command line where we use commands like gcloud and gsutil. And then there's a mobile app. I won't demo the mobile app today, but you can download the Cloud app, the Google Cloud Platform application, onto your Android or iPhone. And there's also the programmatic, the RESTful APIs. And so that's what, there's the console. There's the SDK, which you can download, which gives you tools. You could actually load it directly onto your Mac or your PC, giving you command line control of Google without having to even go up to the web, as long as you've got internet connectivity. There's the RESTful APIs that let me program those. When we're talking this afternoon about machine learning, I'll show you how to use a simple Google API. We use what's called the API Explorer for that. And then there's client libraries, so that my developers go and talk and use GCP. The mobile app, as I said, you can download for your Android, but there's plenty of ways for you to interact based on where your skills and what you do. I'm typically an infrastructure guy, so I use the command line utilities for Google. My developers use the RESTful APIs. And my support desk, if they need to look or start a VM or something, will go and use the Cloud Console. So these tools all come in handy everywhere. What do we have? The Google IAM policy gives you access at a top level. Does it apply all the way down? Yes. Can it be overridden? No. It's a cumulative inheritance model. There's no blocking of permissions. They're all inherited. I like to think of it as a janitor's key ring. If you give me the master key to the whole building, you can't give me another key that stops that. So if I got the master key, all Google Cloud Platform resources live in a project. That is totally true. And service accounts we're going to use for all of these different things. And as I said, as you start to use more and more GCP, you'll get more familiar with these. We use all of them. So some resources.